Hello guys, Leo here, and today I want to empower you with some concepts that will aid you to complete the variables if else while project. I'm not here to spoon feed you with answers necessarily, but to aid you with the knowledge that you need to be able to complete this project and even do much more. So with that said, let's just get straight into it and see what we have here today. Like I always tell you, you don't have to come to the resources first. The first thing you need to do before you come to these resources given to you is to come to the general objectives of the project, the learning objectives. Copy these learning objectives and then pass them as prompts to ChatGPT and allow ChatGPT to explain them to you. And by the time you're done doing that, you should have a very good understanding of the entire concept before you even try your hands on the task. Okay, so copy these things, give them to ChatGPT as prompts, and then you're going to get a very good understanding. And when you find time, you can come back to these resources and read them and get a deeper understanding of the entire project. Okay, so when you go through the requirements and the learning objectives, I put together a few things you need to know to be able to answer this project. So to be able to do the tasks given to you in this project, you need to understand what if-else statements are. You need to know what format specifiers are. You need to know what for loops are, continue statements, nested for loops, ASCII character conversion, how to print variables, arithmetic operators, and logical operators. If you know all these things, then you should be able to answer all the tasks of the project. So what I'm going to do is that I'm not going to explain these things right now. Rather, I'm going to go straight into the tasks concerning this project, and then when we come into a task and we need any of these concepts to be able to solve a task, then I'll explain it, and then I'll come into the task and let you see how that concept is going to help you to be able to solve that task. So let's go straight into the task, and then we'll explain these concepts as we go. So to our first task, we have positive anything is better than negative nothing. This program will assign a random number to the variable n each time it is executed. Complete the source code in order to print whether the number stored in the variable n is positive or negative. You can find the source code here. So let's go for the source code. Then it says that the variable n will store a different value every time you will run this program. You don't have to understand what run all these do. Okay, the output of the program should be, if the number is greater than 0, it should print is positive. If the number is 0, it should print is 0. If the number is less than 0, it should print is negative. Now, for a question like this, you need an if-else statement. Why do I say that? Because you can see that it's giving you options. You use if-else statements when you have various options to choose from. Okay, so let us go into my notes and understand a little bit about if-else statements, and then we're going to come back and try and solve this particular task. So in C programming, an if-else statement is a control structure that is used to make decisions based on certain conditions. Okay, now if you look over here, I say that you typically use an if-else statement when you want your program to make a decision and execute different blocks of code, whether based on whether a certain condition is true or false. Okay, so if you look at our task over here, it's saying that it's giving us various conditions. It says that if a certain number is 0, we should print something, and if it is not 0 or less than 0, greater than 0, we should print something else. So the moment you come across various conditions, you should immediately know that the best thing to do is to use an if-else statement. So how does an if-else statement work? Okay, so let's go try and understand how an if-else statement works. Now, this is the syntax of an if-else statement. The first thing you do is that you have to bring the keyword if, then you bring a condition here. So if this condition is true, then you execute a certain block of code. Else, you execute another block of code. And it is as simple as that. This is how you, this is a simple way of writing if-else statement. It is as simple as that, nothing complicated at all. But sometimes you need to write if-else statements that are longer than 2 conditions. So how do you do that too? Just in case you have some conditions that are more than 2, how do you write if-else statements? So what you do is that you bring your if keyword, and your condition comes here. If this condition is true, then you execute a certain block of code. Then else, if another condition is true, then you execute another block of code. You can keep going on and on and on and on and on and on. Else, if this condition is true, then you execute another block of code. And you realize that I'm putting all my code in curly braces. As you can see, all my code, I'm putting them in curly braces. So now you realize that here in this case, I've given several conditions. If this condition is true, do this. If it's not true, then you come back to else. If this condition is true, then do this. If it's not true, then you come back to the next condition. Else, if this condition is true, then do this. If all these are not true, then your final statement, else do this last thing in curly braces. And if else statements are simple as that. So let's go back to our task and then try and use that to answer it. Now remember that it says that it gave us a certain source code that we need to go and copy. So I clicked on that and it brought me to the GitHub repo of Hexadecimal School. So I'm just going to copy that source code and I'm going to work in Visual Studio Code here. But you're not going to do that. You work in BI. Okay. And I'm going to paste my code over here. Let me minimize it a bit so we see everything. Awesome. So this is our source code that we're going to work with. As you can see, it tells us that more headers go here. What kind of header are we going to put here? In C programming, your header files are part of the standard libraries that you can import to use certain functions in your code. Okay, so one of the very important headers that you need is the standard input and output library. And that header file allows you to use functions such as printf, putchar, put. These are functions that take input and then output text to the standard output. Okay, and without that header file, you cannot use functions such as printf, which we will need to be able to complete this task. Okay, so the first thing you want to do is to include more header files as they require you to do. So we're just going to include the standard input output.h. and we are done with that. Okay, then it says that Betty style doc for function main goes here, which means that you have to put your comment in here, and I know you can do that, so let me not bother myself with that. Let's go straight to the main reason why we're here. Okay, now how do we go about the implementation of the results for this task? All these functions you see over here, srand, time 0, all this, they are just functions that output random numbers to this variable n. Now in declaring a variable in C, remember that you need to bring your data type. Now if you watch my peer learning video, which I've already uploaded to this channel, you are going to learn how to declare variables. You bring the data type and then the name of the variable, and you can choose to assign a value to the variable like this. Okay, but here in this case, they did not assign any value to the variable, so we are just going to leave it as it is. So this is the data type and this is the name of the variable. And then there are also naming conventions for variables, and I've spoken about that too in the previous videos I've uploaded concerning the peer learning day. You can take your time and watch them and you're going to get a very good understanding. So all these are functions that we don't have to worry about. They just print random numbers. Later on, as we are learning, as we are getting deep into the software engineering concepts, we can understand what this does. But for now, we do not need to worry about it. So let us go and try and answer this task with an if-else statement. So I'm just going to start, just like I told you, you start with the keyword if. So it says that, let's go back to our task and answer and get details from there. It says that if the number is greater than 0, print is positive. So let's do that. So let's give a condition. So if n, remember that the variable is n, if it is greater than 0, now this is a Boolean condition. So this is a condition that we're giving over here. N is greater than 0 is the condition. Now we need to bring our block of code over here. Okay, then we're gonna print f. What did they say we should print? It's positive. Okay, so let's print that is positive. But remember that you cannot just print a number in C with a printf function without what is known as the format specifier. Now if you watch the previous video again, you're going to understand what format specifiers are, because I've spoken about them into great detail. But just for your sake, I'm going to go back and then I'm going to speak a little bit about format specifiers in just a second. Now for every data type, there are format specifiers that you need to print them, and there are various kinds of data types. There are integer types, and then the integer types include ints, there are unsigned ints, there are signed ints, then there are the floating data types as well, there are the character data types, and take your time and watch that previous video that I've already done, and you're going to understand data types properly. So there are the integer data types, which are basic data types. The integer types include int, short, long, and char. Then the floating point numbers include float, double, and then there are other derived data types which we are not going to go into yet. However, to print any data type in C programming language, you need what is known as a format specifier. Okay, so to print the integer data type, the format specifier you use is %d. Okay, %d. And to print the character data type, the format specifier you need is %c. To print a string, the format specifier you need is %s. And then there are others over here which you can see. You can pause the video and then read through them. Let us go back to our code and then use the format specifiers in such a manner. Now, before that, if I go into the resources and you look at how the output of the text is supposed to be, realize that when you run your code, you are supposed to get the random number that will be assigned to the variable n, and then it's supposed to print that number, and then it's negative, it's positive, or it's 0. So the way you do that is to use a format specifier. So since it's an integer data type, just like we saw in the notes, the format specifier for the integer data type is %d or %i. Okay, so we are going to say that %d, which is the placeholder for the variable n, is positive, and it's as simple as that. So we are saying that if the number is greater than 0, then we are going to print is positive, and it's as simple as that. And what else are we supposed to bring in our if else statement? Of course, you know, else if, then we bring our condition. Then our next condition says that if the number is 0, we should print is 0. Okay, so if the number is equal to 0, then we bring our code. We're gonna print f %d is 0. Then the final statement, just like I showed you, is gonna be else. Then the last statement is what? %d is negative. Let's put it in curly braces. We actually got a printf %d is negative, and of course we got to bring our variable right here, close our curly braces. We got to bring our variable here. We need a semicolon here. Let's see, this has to be a double equal to, and if you watch the previous video on operators, you're going to understand why this is supposed to be a double equal to. Okay, great. So let's run this code and see what we get. So as you can see, a random number has been assigned, and then it's saying that it's a negative number, which is actually correct, but we are not getting it on the new line. Let's see if one of our instructions was to print on the new line. It assigns a random number. We are not required to print on a new line. We may decide to or not do that, but just to have a very clean code, let's put all our print statements on new lines, and to do that, you use \n. So let's print our code again and see what we get. So as you can see, we have a negative number again, and it says that it's negative. It's actually correct. Again, we have a negative number, so we could keep running and running and running and going. We keep getting negative numbers, no positive numbers, but that's okay. It says that this number is negative. Our code is working correctly. So basically, what we have understood about if-else statements is that they are conditional statements. You use them when you have various conditionalities to meet. If I don't go here, or if I don't do this, then I'll do this other thing. Okay, and that is how you use if-else statements. So if this condition is true, then do this. Else, if this condition is true, then do this. Else, do this final thing. Then definitely we need to return 0, because our int main function is an integer data type, so we return 0. I've also explained that in the previous video. You need to watch that. So our first task is done. Let's go straight to the second one. So our second task, which is actually task 1, also says that this program will assign a random number to the variable n each time it is executed, which is similar to the first one actually. Complete the source code in order to print the last digit. So take note that we are supposed to print the last digit of a number stored in the variable. Okay, we can find the source code here, so I'm just going to click on that. The variable n will store a different value every time you run this program. Then remember that these are the functions to print random numbers. Then they go on to tell us that the output of the program should be the string last digit of followed by the variable followed by is followed by, if the last digit of the variable is greater than 5, then the string and is greater than 5. If the last digit of the variable is 0 and 0, the last digit is less than 6 and not 0, then we print this. Okay, the moment you see, like I told you, the moment you see conditions, you should know that you definitely need an if else statement. But then if you look into these conditionalities carefully, you realize that we are going to need something called logical operators. So let's just go and understand what logical operators are, and then we already know what if else statements are. So let's go understand what logical operators are, and then we're going to come back and try our hands on this task. And when we run our code, this is the output that we should be getting. The last digit of the number, the variable, is this, and is less than 6 and not 0. So something like that. Okay, then we should, this is the output that they are saying we should get. Assuming we get this number, the last digit is -7 and it's less than 6 and it's not 0. Okay, so let's go and understand what logical operators are, and then we'll come back and try our hands on this code. So here in my Evernote, there are several arithmetic operators that you can have in programming. Okay, there is addition operator, 1 + 1 = 2. There's subtraction, 2 - 1 = 1. There's multiplication, division. But what I want to talk to you about here is the modulus operator, and then we'll also speak about logical operators. Okay, now this operator, the percent operator you see over here, is known as a modulus operator. Okay, so let's go and try and see how that particular operator works. Assuming I have, this is the operator we are dealing with. Assuming I have a number, let's say 171. Okay, now if I say 171 modulus 10, what I'm simply saying is that I'm dividing 10. I'm dividing 171 by 10, and the remainder that comes up is my answer. So if I divide 171 by 10, so let's do a long division here, and I put in 171. You know that I'm going to go into this 17 times. Okay, then that answer gives me 170. So I get a remainder of 1. So the modulus of 171 and 10 is 1. Does that make sense? So let's try another answer on another one. Let's say 11 modulus 10. I'm simply saying that 11 over 10. I'm looking for the remainder, and this is also 1. So let's try something else. Let's say 3 modulus 10. What's the answer supposed to be? When I divide 3 by 10, I can actually divide it, and we have a remainder, which is 3. So 3 modulus 10 is 3. Okay, so any single number between 0 to 9 modulus 10 gives you the same number. And the trick about, let me just clean this so that we have a fresh screen. And the trick about the modulus operator is that whenever you divide any number at all by 10, it will always return a single digit. Okay, so assuming I divide, let me just write any random number, 171691132. Okay, no matter what the number is, when I divide this number by 10, it was going to give me a certain number and a single digit remainder. So you realize that even without calculating this and just looking at it, you can tell that I'm going to get a remainder of 2. When I divide this by 10, it will divide it by a certain number, and I'll definitely get a remainder of 2. Okay, assuming I divide 61 by 10, I'm going to get a remainder of 1. Assuming I divide 83 by 10, I'm going to get a remainder of 3. So this is how the modulus operator works. It simply divides the number and gives you the remainder. Okay, now let's go and understand how logical operators also work. Now, there are 3 main logical operators in C programming, practically every programming language. They are the ampersand operator, the 2 vertical line operator, this, which is what you see here, and then there is a not operator, which is an exclamation sign. So how do these operators work? The ampersand operator, the ampersand operator, it's a conditional operator. Okay, so it's like it's gonna compare 2 things, and they are gonna end up as true or false. But the interesting thing about this ampersand operator is that both conditions must be true before the whole thing will evaluate to true. Assuming we have a condition A, okay, and then we have ampersand B. This comparison over here, A must be true and B must be true before all this will evaluate to true. If one of these conditions is false, it means that this entire thing is going to evaluate to false. But then the double vertical sign works a little differently. Assuming we have the condition A, 2 vertical signs, and the condition B, only one of these conditions have to be true for all these to evaluate to true. Okay, so assuming A is true and B is false, then the entire thing will be true. Assuming A is false and B is true, everything will evaluate to true. But if both of them are false, then this will evaluate to false. But for the ampersand operator, it means that both conditionalities must be true before all this will evaluate to true. As the moment one of them becomes false, the entire thing is false. And then the not operator, which is an exclamation sign, negates the whether it's true or false. So if you have the not operator and the condition which is true, that means that it's going to reverse it to false. Okay, so the moment you see the exclamation sign, you are simply saying not. Okay, so assuming I have a condition called A, which is true, the moment I bring this, it means that I've reversed the condition to false. And one more thing you need to understand is that in C programming, true is 1 and false is 0. So whenever I bring 1 in a logical operator, I'm referring to something which is true. When I bring 0, I'm referring to something which is false. With that at the back of your mind, we can try our hands on that particular task. So let us go for our source code which we were given. We're going to copy this source code. Then I'm going to delete everything that I have over here which we worked on the first time. I'm going to paste the new source code in. Wonderful. And it's telling me that more headers go here. Of course, I'm going to include my standard input and output library. So I'm going to include standard input output.h library. Wonderful. And I told you that if you watch my previous video, you understand why we need to include this library, because we're going to use functions such as printf, which is included in this library. So our task is telling us that if the last digit of the n, the variable, is greater than 5, then we should print and is greater than 5. Okay, then the output should be something like last digit of the number is this something, is whatever, and is greater than 5. So let's go work on that first, and definitely you know we are going to use an if else statement. Before that, don't forget to put your comment in here, a Betty coding style comment style. Okay, and I'm not going to go into that because I expect that you should be able to do that. If you don't, just go into the previous tags videos and you're going to know how to do that. Let's write our code over here, because that's where the indicator we're supposed to write our code. Now the if else statement, just like I told you, begins with the keyword if, then you bring a condition in parentheses. We are trying to determine if the last digit of a certain number is greater than 5. What operator do you think we can use to do that? And I've already explained to you that it is the modulus operator. Why is it a modulus operator? Because when you divide, it gives you the remainder of that division. Okay, so if we divide any number at all by 10, you realize that it's going to give us a remainder of the very last number. So to be able to tell the last digit of a number, one of the most effective ways to do it is to divide that number, no matter what the number it is, by modulus 10. Remember that over here we are dealing with an integer, so we are dealing with whole numbers. The integer in the source code, the variable in the source code that they gave us is an integer, so we are dealing with integers. Okay, so we are going to say that if, let me bring another parenthesis, if the number modulus 10 is greater than 5, okay, remember I told you bring your curly braces and your block of code comes in there. So we're going to print f. What is the format specifier for printing an integer? So let us go and see the format in which we are supposed to print. The last digit of is where we are supposed to print. So the last digit of, as a matter of fact, let's just copy everything and go work on it. Bring our quote unquote, then the last digit of the number. Now remember that you cannot put in a number here, you're supposed to use the format specifier here. So the last digit of %d is %d and is greater than 5. You bring your semicolon. But before that, you need to bring in, whenever you bring the format specifiers, you must always indicate what variables these placeholders are signified to. So the last digit of definitely n is n modulus 10. Now why is this so? Because the last digit of the variable n is %d, and over here we are looking at the last digit itself, so we need to indicate that it's modulus 10 so that it can print out the last digit for us and is greater than 5. That's if the condition is that the last digit of the number is greater than 5, as we have indicated over here. So we have satisfied our first condition. Let me just, great. So we go to our else if, remember just as I told you, and let's go to our task and see the next thing that we were told. If the last digit of n is 0, the string is 0. Okay, so that's straight to the point. The last digit of n is less than 6 and not 0, the string is less than 6. So let's go in there and let's just find something similar and let's use that. So let's pick this condition. Then we're going to bring our curly braces. So definitely we're going to say the last digit of %d. Let's work on the condition now. We're looking at a number which is supposed to be less than 6, and yet it is not 0. So over here, you realize that we need two conditions that are both true. We need two conditions that are both true. We're going to say the number modulus 10, which is the last digit, okay, if it is less than 6, and yet another condition must also apply. This same last digit, which is the number modulus 10, you know why the last digit is n modulus 10. Remember, I spoke to you about the not operator. So I'm going to say it's not equal to 0. Does that make sense? Let's run through this and see if it's making any sense. We are saying that n modulus 10, so whatever the n is, whatever the number is, when you divide it by 10, it gives you the remainder. So it definitely gives you the last digit of the number n. Okay, so if the last digit of n is less than 6, ampersand, I explained to you that it means that the condition here and the condition here must all be true before everything will evaluate to true. So we have two conditions here, and both of them must be true. Okay, else if the last digit is less than 6 and the last digit is not 0, then what should we print? And we're going to print the last digit of the variable n is this. So it's definitely going to be %d, and then because we are dealing with integers and it's less than 6 and not n, we're going to bring our variables in here. So our first format specifier is n, and our second is actually the last digit, so it's going to be n modulus 10. Does that make sense? Now let's go see the last condition, which is 0. Let's see how it says we should put it. It says the last digit of this is 0 and is 0. Okay, so let's check that condition, which is this one. The last digit of the variable is 0 and the string is 0. So let's go implement that. So since that's the last condition, we're just going to say else. We bring our curly braces. We're going to printf our parenthesis, and let's paste this code in and work on it. So the last digit of %d, we got to make it small n, small d, is %d, and it's 0. So bringing our variables, and now let's put everything on the new line. Okay, so let's put this on the new line. Remember, I told you the new line is \n. Okay, so let's run this code and see what we get. The last digit of this is -8 and it's less than 6 and not 0. Our code seems to be working fine. The last digit of this is -2 and it's less than 6 and not 0. The last digit of this is 0 and is 0. The last digit of this is -5, is less than 6 and not 0. Our code is working fine. It's working. So as you can see, this number modulus 10 is definitely going to give a remainder of -5. It's a negative number. It's less than 6 and it is not 0. Our code is working fine. So let's run through it and then see what we have here. First, what we did is that the if-else statement is if condition block of code. Remember, if condition block of code, if condition block of code. Never forget that. So we said that if this condition is true, then print this. What is the condition? N modulus 10. A random number modulus 10, and any number modulus 10 will always return a single digit. Okay, it will always return a single digit, and it will return the last digit of that number. All right, now, so the number modulus 10, if it is greater than 5, we're going to say that it is greater than 5, and we are making use of our format specifiers here. Okay, now in the second condition, we are saying that else if the number is less than 6, and which is a logical operator. Now I told you that both here and here must be true before everything will evaluate true for this statement to be executed. So if the last number is less than 6 and that same number is not 0, then we are going to say that it is less than 6 and not 0. We are making use of our variables and format specifiers. Then the last condition is that else if both first two conditions are not true, we are going to say that the last digit is 0. We are making use of our format specifiers here in our variables. It is really simple and straight to the point. Let's go to our next task. Okay, to our task 2. It says that we should write a program that prints the alphabet in lowercase, followed by a new line. You can only use the putchar function. Every other function, printf, puts, etc., is forbidden. All your code should be in the main function. You can only use putchar twice in your code. Now, this simply means that for us to be able to answer this task, we need to know what the putchar function is and what it does. We need to know what the main function is, and then we are also not going to use the standard library functions such as printf. All right. Okay. So go ahead, create your files, and then let's see how we can answer this code. If you look at it carefully, we are supposed to output exactly this when we run our file. Okay. So it's supposed to print the alphabet from A to Z. Now the question is that putchar is a function which only prints a single character. Putchar only prints a single character. So let's go into my Evernote and find out how we can solve something like this. Whenever you come across a task in programming, the first thing you need to do is to come up with a thought process. Okay, so I always like to work with a pen and a paper. I take my pen and a paper and I write, how can I do this? You see, that is a thought process. That is what you should do when you are programming. Take a pen and a paper and then start asking yourself questions. How can I implement this in code? What should I do first? How can I go about it? And that is the most important thing before you start writing out your code itself. So we've been asked to print the alphabet from A to Z. Okay, are we going to do put car A, put car B, put car C, put car D? Are we going to do that all the way to Z? Is that a very effective way to do it? But ALX has also told us that we can only use put car in our function twice. So how exactly can we go about this? Now, that is what brings us to what is known as loops in programming. Okay, loops. What are loops in programming? What is a loop in English? A loop is simply something that loops around. Okay, so you start from here and then you loop around and come to the same point. You start from here, you loop around and come to the same point. So this is what a loop is in basic English language. So now, how can we use loops in programming to solve certain tasks that will appear repetitive? Okay, in C programming, basically every programming language, there is what is known as the for loop, and there is also what is known as the while loop. Of course, there are other kinds of loops. There's also other kinds of loops such as the do while loop. But how do all these things work? Now, this is the syntax for the while loop. While a certain condition is true, you are going to execute a certain block of code. Do you see the syntax? It's very simple and straight to the point. While a certain condition is true, execute this. As long as the condition is true, we are going to keep executing this. But the moment the condition becomes false, then the loop breaks. Does it make sense? So let's clean our board and also understand how the for loop works. So now, for the for loops, you're going to say for. Then the for loop has three very fundamental parts, which I like to use the acronym ICU. The I stands for the initialization, the C stands for the condition, and the U stands for the update. Okay, so you're going to say that for, then the first thing you come to is your initialization. So let's say we have a variable we have already declared, probably called I. So we're going to say that we are going to initialize our variable at a certain figure, and usually when you initialize your variable at a certain figure, it's going to be the first iteration of the loop. So you can decide to initialize it from 0, from 1, from A, really depending on what you want to do. So let's say we initialize our variable from 0. Then after that, after the initialization, you bring a semicolon. Then you bring your condition. At some point, you have to bring a condition that becomes false, or else your code is going to keep running and running and running. Okay, so now we're going to bring a condition that our I should probably be less than, let's say, 5. And when you're done, you bring your semicolon. Then you're going to increment or decrement your variable so that at some point this condition becomes false, so that the loop can break. So we're probably going to say I++. We have already spoken about what this operator means. We are going to close our parentheses, open curly braces, then a block of code comes here, then we close our curly braces. So basically, what a for loop does is that it has this initialization, and after the initialization, we have the condition, and after the condition, we have the update. Does it make sense? After which we have the do while loop. The interesting thing about the do while loop is that it does the block of code. So it does this code while this condition is true. That's very interesting. It's similar to the others, just that the block of code is executed while the condition is true. So for instance, even if the condition is here is false, okay, the block of code is going to be executed first. Then it comes to realize that the condition is false. Then it's not going to execute it again. But when it comes and realizes the condition is true, then it's going to keep executing and executing. Okay, but the interesting thing about this is that it executes it first for the first time before it checks whether the condition is true or false. All right, now let's go and implement this in code and see how they actually work, because this is what we are going to need to answer our task. Let's go into my Evernote on loops, and then let's see if we can read a few things. All right, so for the while loop, it says that a while loop in program is a control flow statement that repeatedly executes a block of code as long as a specified condition is true. So while the condition is true, it executes a statement, and it's as simple as that. Then the for loop, it has three aspects. It has the initialization, it has the condition, and then it has the update. Okay, so for, then you bring your initialization, you bring your condition, and you bring your update or your increment, and it's as simple as that. Let's go into my Visual Studio Code, and then let's try and implement this and see how it works. So let's enter the basic structure of a C program. Awesome. Now that we have our basic structure, let's try a while loop and let's see how it works. So we are going to say while, let's bring a condition which is true. So while 1 is less than 5, let's print this is code. Let's run this and see what happens. Do you see what is happening? The code is going to keep running and running and running until we run out of memory. And why is it so? That is because this condition will always be true. 1 will always be less than 5. So as long as 1 is less than 5, this code is going to keep running. So what can we do? At some point, we have to ensure that this condition becomes false. All right. So let's declare a variable. Let's call it I. Okay. So we are now going to say while I is less than 5, let's give I a value. Let's say 0. Okay. So we are going to initialize I at 0. So while I is less than 5, you're going to print this code. And this is less than 5, so it's going to keep printing and printing. So what must we do? We must ensure that our condition at some point becomes false. So we're going to increment I. So what is the control flow of this code now? I is initially 0. Is I less than 5? Yes, it is true. So we are going to print this code. Now we come down, we are going to increment I. So I plus plus is an increment operator. So I becomes 2. Then it comes back again. Is 2 less than 5? Yes, it prints. Then it comes back, I becomes 3. Is 3 less than 5? Yes. It comes back, prints this code. I becomes 4. Is 4 less than 5? Yes. It comes back and prints. Is 5 less than 5? No. So our condition is going to become false and the loop is going to break. Okay. So, no wait. Let's put our increment operator inside this code, or else it's still going to be an infinite loop. Okay. So it's going to print and then increment it. So let's run this code and see what we come up with. Great. It says this is code, this is code, this is code. It's printing it a number of times according to our iteration. So let me clear my terminal and then run the code again so that we can see clearly. So let's put this on the new line so that it comes out really clearly. So we're going to put this on the new line and run our code. As you can see, it's running the code 5 times because we initialized it as 0 and then we brought a condition and ensure that at some point the condition becomes false. So it's going to print it a number of times and we have broken the infinite loop. So this is a while loop. How does the for loop also work? Okay, so we are still going to use our variable I. Okay, then we are going to say for I equals, let's initialize it as 0. Remember, first condition, the first statement is going to be your initialization, then the next is going to be your condition. So at some point I must become false. So let's say I is less than 5. Then the last is your increment, so I plus plus. Then what are we going to print? As long as this is true, let's print this is code. So let's run this loop and see what happens. Awesome. So let's put that on a new line. As you can see, our loop is working perfectly. So loops in programming are a very simple way by which you can perform repetitive tasks easily. And if you look at the task that we are trying to answer currently, it says that we should print the alphabets from A to Z. No, we cannot use putchar more than twice in our code. So the only way by which we can actually do this is by using loops. So let's go try this out. Since we are printing alphabets or characters with putchar, we definitely must use a character data type. Okay, we are going to say char, let's call it alphabet, since we are printing the alphabet. Now we are going to say that for alphabet equal to A, all right, because we are initializing our alphabets at A. Alphabets always start at A. We are going to say that alphabet should be less than or equal to what? Z, because it ends at Z. And then at the end of the day, we are definitely going to increment our alphabet. Then remember that we've been asked to use putchar. So we are going to putchar our alphabet. All right. Bring a semicolon. So let's run this code and see what happens. As these characters, it has to be in single quotes. We're good. So let's run this code and see what happens. As you can see, we've been able to print the alphabet from A to Z with just one function, putchar. We've been able to print the alphabets from 1 to Z. I'm going to clear my terminal and run the code again so that we see it clearly. However, it's not on a new line. So you can see that my username is appearing right after it. One of the instructions in the task is that we should print it on a new line. And we've been given the opportunity to use putchar twice. So definitely, let's use that. So outside of our loop, we are going to come and use putchar again. We're going to print a new line. So as you can see, now we have our alphabets printed out with a loop. Let's go through our code and see what we did here. So first of all, we give our preprocessor directive, or our function is in the main function. We've already explained this in previous videos. Then we declared a variable. We called it alphabet. You can call it anything. Just make sure that your variables are really descriptive. Okay. Then we said that for alphabet, we are initializing, because remember I told you that a for loop has three parts. It has the initialization I, it has the condition, and then it has the update. Okay. So we initialize our alphabet variable at A. Then we give a condition that our alphabet should be less than or equal to Z. So it's going to run all the way from A to Z. And we give our alphabet an increment operator. So what's going to happen? This is the way for loops are executed. So you have the for, you have your initialization, you have your condition, and you have your update. Then you have your code, which will be executed here. Okay. So now it checks the first value of your variable. Okay. Now, let's say you initialize it as 0. So it comes to check. Let's say you said that this should be less than 5. So it comes to check. Is the variable 0? Is 0 less than 5? It sees that the condition is true. So it moves from here to this place. If the condition is true, it's not going to go to the update yet. It's going to come down and then execute this block of code. Then when it is done, it will go to the update. And then it's going to increment or decrement depending on what you said. So now the variable becomes +1. When it's done, it comes back to the condition and checks. Is 2 less than 5? Yes, it is true. It doesn't go back here. It comes down to the code and then executes the code. Then after executing the code, it goes back to the update. +1, it becomes 3. Is 3 less than 5? Yes, the condition is true. So it comes back to the code, executes the code, then goes back to the update. The update becomes 4 because it's ++. Is 4 less than 5? Yes. So it comes back to the code and executes and goes to the update. It becomes 5. Is 5 less than 5? No. Then the loop breaks. So the moment the loop breaks, it comes out of the loop and then goes to continue the rest of the statements outside of your curly braces, because the loop is now broken. All right. So assuming you have another function here, let's say put car, and you want to print, let's say, a new line, so it just goes ahead and prints it because it has come out of the loop, which ends with the curly braces. If that makes sense, then you understand how we were able to solve this task. Okay. This is really simple and straight to the point. So let's go to our next task. Now our third task says that write a program that prints the alphabet in lowercase and then in uppercase. Okay, so we're going to print the alphabet in lowercase and then in uppercase, followed by a new line. We can only use putchar. We can't use this. All our code should be in the main function. We can only use putchar 3 times. And then I always like to come to check how the output of the code should look like, because it gives me a visual idea of what I'm supposed to do. So over here, we are supposed to print all the alphabets from A to Z in lowercases, and we'll print from A to Z in uppercases. Right? That's interesting. So let's go try that out. I think this should be pretty easy because we've already done this, which prints the alphabet in lower cases. Okay, so when we run this code, what we got is the alphabet in lower cases, and it's still here. Okay, so what we're going to do with this one is that we are just going to duplicate the for loop. Okay, we're just going to duplicate the for loop. So I just copied this code and repasted it here. We are doing the same thing, don't get confused. All right, so we declared our character variable, we called it alphabet. Then we initialize the loop. We said for alphabet equals small a, it should be less than or equal to Z. Then we incremented it just like we've already explained. And if the condition remains true, we're going to keep printing the character. We keep printing until the condition becomes false. Then we came out and then created another loop. We are like, for alphabet equals, this time around we're supposed to print capital letters. Then it's going to be less than or equal to, of course, capital Z. And we are going to increment it. We're going to print our variable alphabet. All right, then we'll print putchar on a new line. So let's run this code and see what we get. So we are printing an alphabet A to Z, then we are printing capital A to Z. It's really straight to the point and simple. So let's not waste a lot of time on this. We're done. So to our next task, it says that write a program that prints the alphabet in lowercase followed by a new line. It's basically the same thing we did. However, this time they're saying that we have to print all the letters except Q and E. We can use putchar, and then our code should be in the main as usual, and then we can use putchar twice in our code. And I always like to come see how the output of the code should be. So we are going to print all the alphabets, but I see E omitted, and I also see Q omitted. So we are going to use the same for loop as you have already seen, but this time around we can see that there is an exception. We are supposed to omit some letters. There are several ways by which you can do this. Actually, there are several ways by which you can do it, but then to be able to do it the way I want to show you, I need to introduce you to something called a break and continue statement. A break and continue statement. So let's go to my notes and let's see if we can learn in a minute what break and continue statements are. A break statement is used in terminating the loop whenever it is encountered. So if you use a break, it means that the moment a loop is encountered, the loop is going to cease. Then a continue statement is used to skip the remaining code within the current iteration of a loop and move on to the next iteration. So let's say we are running a loop, okay? So we have our initialization. Let's say our I equals 0. Let's say our I is less than 5. And let's say we increment our I. Definitely we're going to run our code. Okay. However, if you use the continue statement, so let's say you bring a condition that if our I, let's say, is equal to 3, continue, then we close our loop. What is going on here? What's going to happen here is that, as we have seen, this code was going to run all the way from 0 until the iteration becomes false when I becomes 5. But we have brought another condition here that if our I is equal, we have to use the double equal to sign, is equal to 3, we should continue. This continue statement breaks the loop of the current iteration when I is equal to 3. It means that the moment I becomes 3, it's going to skip that particular iteration. So that is what a continue statement is used for. So if we're going to answer attacks, we are supposed to skip kill and E. So the moment our variable becomes kill, we are supposed to skip. And the moment our variable becomes E, we are supposed to skip. So let's go try and implement that in code and see how it's going to look like. So let's get rid of this. We're using the same variable. So we have declared a variable alphabet. We are saying that for our alphabet equals A, it should be less than or equal to Z, just as you've already seen before. However, we are about to add a condition here. We're going to use an if statement. We've already seen if else statement in our first task. But the interesting thing about if else statement is that you can use the if statement without the else, but you cannot use the else without the if. So I can just say if something and omit the else. If statements work that way too. So I'm going to say that if my alphabet is equal to the character E, or does it make sense to you? I'm going to explain that, don't know. Or if my alphabet is equal to the character Q, then continue, which means a skip. Okay, skip. Let me explain what I've done here to you. You already understand this for loop because we've used it in the past 2 tasks. Now, in addition to the for loop, I'm giving a condition here that if my alphabet equal to E is E, then remember I explained this or logical or operator to you. There is a logical and, which is ampersand. There is a logical or. So I'm saying that with a logical or, either conditions if one of the conditions is true, then all of them evaluate to true. But with a logical ampersand, if one condition is true and the other is false, then everything will evaluate to false. And I've already explained that. So here I'm saying that if the alphabet is E or the alphabet is Q, then skip. Continue the rest of the code. So it's going to skip when the loop gets to these iterations. Does that make sense? So I'm going to run a code and then let's see what comes up. So I have A, B, C, D, E. For some reason we still have our alphabets we are trying to skip here. So let's go in there and try and fix it. And we can see the error over here. It says the error is generated from the semicolon over here. Okay, so let's get rid of this. Let me run my code and see what the problem is. It still indicates that there's an issue. Let's debug. I like to debug. So what do we have here? The loop is okay. So we are supposed to take this and bring it after the continue statement. Why is that so? So for our alphabet equals to this, our loop is running. Okay, we have to bring the condition before we print our alphabet. Okay, so if our alphabet is E or the alphabet is Q, then let's continue, which means that we are going to skip and then we're going to print the rest of the alphabet. So let's run this code one more time and see what we have here. Awesome. So as you can see now, we are skipping the E and then we are skipping the Q. Our code is working correctly. Wonderful. So let me clear this terminal and then run the code one more time. Great. We are skipping the E and the Q now. Wonderful. So what you want to do is to make sure that you bring in the condition within the for loop before you print your alphabet. Okay, it's as simple as that. Okay, now so to our next task. Write a program that prints all single digit numbers of base 10 starting from 0 followed by a new line, and all our code should be in the main function. And this time around we are not being told not to use any other function, so we are free to do anything we want to do. Then this is our output we are expecting from 0 to 9. That seems pretty straight to the point. Let's go try it out. So what are we expecting? All the single digit numbers of base 10 are from 0 to 9. What do you think you can do? What concept do you think you can use to do this? We've been doing it all this while. I think it's really simple. So you're just going to use a for loop and you're going to print from 0 to 9, which means that it should be less than 10. Okay, you should be able to do this really straight to the point. So since we are printing numbers, we don't need characters, we have to use an integer. Okay, then remember I told you that your variables must be really descriptive. Okay, so we are going to say single, or let's use a camel case. Let's say single digit base 10. That is kind of long. Let's try and shorten it a bit. So instead of saying digits, let's say single dig base 10. Okay. So let's change the variables of our for loop. So I'm gonna say we are going to initialize it as 0. All right. And we are gonna say that our variable should be less than 10. Remember, we are printing from 0 to 9. Then finally, we are going to increment our variable. Then what are we going to do inside our block of code? Let's get rid of all this. We are simply going to printf. What format specifier are we going to use? We are printing an integer. Yes, I heard you say it. %d. You're so smart. Then we'll bring in our variable name. That's a semicolon. Don't forget to get rid of this. Okay, so let's just print our code and see what we get. So we are printing 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. Let's go see our output and see. There's a new line here. Okay, yes, followed by a new line. So let's go and add a new line to our code. So let's print it out again. No, this is not how it's supposed to be, meaning that our new line shouldn't be here. Our new line should come out of the loop. So we're gonna printf. So let's try it out again and see. Wonderful. So as you can see, we have the same as the output of the internet. It's a simple for loop. This is what we've been doing all this while. We declared our variable, then we initialize our variable at 0, then we said it should be less than 10. This is our condition. Then we incremented it, then we printed the variable itself. So just like I explained to you, the loop is going to come here, initialize at 0, check the condition is true. It doesn't go to the increment first, it comes down to the block of code and it prints the variable. When it is done, it increments. I becomes 1, then it comes, I becomes 2, I becomes 3, all the way to I becomes 10. Is 10 less than 10? No, then the loop breaks. Now it comes out of the loop to print a new line, then it returns 0 as usual. So this is also really straight to the point. Let's move to our next task. Numberz. Write a program that prints all single digit numbers of base 10, starting from 0, followed by a new line. And this time around, you are not allowed to use any variable of type char. You can only use putchar function. Every other function is forbidden. That's an interesting one. You can use putchar twice in your code. All your code should be in the main function. So basically, we are printing the same thing. Okay, we are printing the same thing. However, we can't use the printf function just like we did in the first one. We are going to use putchar. Putchar is used to print characters, and yet they are asking us to use it to print numbers. So how are we going to do this? And our numbers is supposed to print single digit numbers of base 10 starting from 0. So how are we going to do this with putchar? And then also we are being told that we cannot use character variables. That's really interesting. So let's go see how we can implement that in code. Basically, our loop is going to remain the same. Remember, we are told not to use char, so we are still going to declare an integer variable. Then we're going to initialize our loop at 0 as usual. Then this will be less than 10. We are printing from 0 to 9, and then we're going to increment it. But this time around, we've been warned not to use printf. Okay, so let's get rid of printf and use the function we were asked to use. We're going to use putchar, but putchar only prints a character. We can't use a format specifier. So how do we go about this? Now remember that I explained to you that the modulus operator returns the single digit of a number. So if you are going to return the single digit of a number, I explained to you that whenever you divide a number by 10, it will always return a single digit. Okay, so now if we say that our variable, which is single digit base 10 modulus 10, let's put that in parentheses. Okay, now so what this does is that it's going to divide whatever our variable is by modulus 10. So let's run this loop and see what happens. we initialize our loop at 0. Then we check our conditioning. Is 0 less than 10? Yes, it is. So remember I told you it doesn't go to the increment first. It comes down to execute the code. When it comes to execute the code, it encounters another function, put car. Okay, our variable is currently 0 in the current iteration that we are running. So 0 modulus 10 is what? 0. And then there is also something called RC values. RC values, okay? ASCII, American Standard Code for Information Interchange. Okay, so you want to make time and go and read on what RC is. It's a universal code system by which characters are paired to numbers. So for instance, in ASCII, A is paired to the number 65, B is paired to 66, and it goes on and on and on. Small a is also paired to another number. I don't have it offered. I think it's 97 or something. I'm not too sure. And even symbols such as at and other symbols such as pound and all have their pair in the ASCII notation. Okay, so in order to print a number using putchar, you need to print their ASCII character representation. And the way to do that with the putchar function is to add the number you are trying to print to the character 0. Okay, in single quotes. We bring a semicolon. Okay, so let's run this program and see what comes up. As you can see, we've been able to print from 0 to 9. Let me clear my terminal, run it and see. So we've been able to print from 0 to 9 using putchar. Let's run through this code. We declared our variable, then we initialize our for loop at 0. Then the condition is checked. So let's check for various iterations. Let's say we have come to increment and our variable single digit base 10 is now 5. Is 5 less than 10? Yes. So when the code block is about to be executed, it's going to be 5 modulus 10. What is 5 modulus 10? The answer is 5. Then 5 is going to be added to this ASCII character notation to be converted to the character 5. Then it's going to go to the next iteration. So our variable becomes 6. Is 6 less than 10? Yes. Then the code will be performed all the way until our variable becomes 10. When the variable becomes 10, then the loop is going to break. It's going to come out of the loop and then print a new line. It's as simple as that. Write a program that prints the lowercase alphabet in reverse followed by a new line. You can only use putchar. All your code should be in the main function. You can use putchar twice in your code. And this is the output they are looking for. So we are looking at printing from Z to A in reverse. I think this is also quite straight to the point and you can do it. You can do it. Okay, so since we are, let's see if they access to use character. Yes, we're not asking not to use character, so we can use a character variable. So let's initialize a variable character, and once again let's call it alphabet, since we are printing the alphabet. Or we can let's change the variable name. Let's call it alphabet reverse. Okay, that's cool. All right, now we are going to initialize at Z. You know why, right? We are going to initialize as Z because we are going to start our print from Z and it's a character, so we put it in single quotes. Then we're going to get rid of this. Our new variable is called alphabet reverse, and it's supposed to be what? Greater than, come on, A. I can hear you say, because we are printing all the way from Z to 8 to A. We are printing in reverse. Okay, then when we are done, are we going to increment or decrement? I heard you say it. We are going to decrement because we are reducing it. So we are reducing all the way from Z to A. You're so smart. Then let's get rid of this. We are going to putchar the name of our variable alphabet reverse. Let's run this code and see what we get. So as you can see, we've been able to print all the way from Z to B. Why is it Z to B? So it's supposed to be greater than or equal to A. Okay, because it's greater than A, that means it's gonna end up B. So let's print this and see what we get. So we have Z to A now. Okay, so this is a very simple task actually. So you initialize your variable, it's a character, so car. Then you start your loop, initialize it at, you declare your variable, initialize it at Z, then make sure it's greater than or equal to A, then you decrement it, all right? Then you print or putchar your variable, and then of course you have to print a new line as well. Hold on, we can't use printf as you were told, so we gotta putchar a new line in single quotes. You use putchar, use single quotes. Let's print it out and see. We have Z to A. This is a really simple task. The next task is hexadecimal. Write a program that prints all the numbers of base 16 in lowercase, followed by a new line. We can only use putchar function. Our code should be in the main function. We can only use putchar 3 times in our code. And this is the output that they are expecting. from 0 to 9, and then from A to F, and that is the hexadecimal notation. Okay, so from hexadecimal, just like we have 0 1 for binary, then we have 0 all the way to 9 for decimals. In hexadecimal, we have 0 all the way to 9, and then we also have A, B, C, D, E, F. So A represents 10, B represents 11, C represents 12, this represents 13, and so on and so forth. Okay, so that is what they want us to print, and I think this is also straight to the point. We are still going to use a for loop. It looks like today's project, most of the requirements is for loop. You could actually try and use a while loop for some of them. We'll try that, but I think it's easier if you implement it with a for loop. Let's not try and knock a nail into the wood with a knife when we can use a hammer. Okay, so we're going to print this time around. We're going to print both numbers and alphabets. So you see, we are printing numbers, then we'll print alphabet. So it looks like we're going to need 2 loops, right? Yes. So let's initialize, let's declare 2 variables. So let's do int number, okay, and then car. We're not going to reverse our alphabet anymore, so we're going to do number and alphabet. Okay, then for our first for loop, we're going to initialize our number at what? 0, because we are printing from 0. Then what should the condition be? Our number should be less than what? I can hear you say it should be less than 10, because we are printing from 0 to 9. It doesn't have to be less than 10 necessarily. You can even say that it should be less than or equal to 9, or less than 10. It's actually the same thing. And then what are you going to do? You're going to increment it to ensure that our condition becomes false at some point. And then we are using put car as we've been asked to do. So we are going to print our number. Well done. Remember, we are doing 2 for loops because we are printing numbers and alphabets. Then now we are going to bring our alphabet and initialize it at what? Wonderful. Hey, I heard you say. Then what will be our condition? Our alphabet should be what? Should be less than, come on, say it. Should be less than or equal to F. You're doing well. Then what are we going to do? Are we incrementing or decrementing? Very good. You're so smart. We are incrementing. Okay. Then in our block of code, we are going to put car, our alphabet. Wonderful. Then when we're done, we print a new line. So let's run this code and see what comes up. Okay, F is a character, so we can't just leave it hanging like that. We need to put it in single quotes. Let's run our code again. What do we have here? We have A, B, C, D, E, F, and then the first one didn't come out. That's very interesting. Why is this so? Of course, we know why it is so. Because we are using the function putCar. If we're using printf, then we could have just use a format specifier and then gone our way. But this time around, because we are using putCar, we cannot do it just like this. We need to use the modulus function. So we're going to divide by 10, and then as usual, we're going to add it to this to change it to the ASCII character representation. I've already explained that in the previous task. So let's put this in parentheses so that we have a very clean code. Okay, so let's print that and see what we come up with now. So we have hexadecimal from 0 to 9 and then A to F, just as our output wanted. So what do we have here? We declared 2 variables, num and alphabet. Then we started our first for loop. We initialized it as 0. We gave a condition that it should be less than or equal to 9 and incremented it. Then we use a putCal function, that number modulus 10. So whatever our number is in each iteration is going to be modulus 10. And modulus 10 is just going to pass the same remainder. So if it is 8, it's going to be 8 modulus 10, which will be 8. Then we add that to the ASCII character representation. Okay, so it converts it to the character representation. So assuming we get 8 over here, because we are using putCar, it's only printing characters. So now you need to convert it to the ASCII character representation. So we add it to the 0 in single quotes and it does that conversion for us. Then now we come to our second for loop. We initialize our alphabet at A, and the condition is that it should be less than or equal to F. We run our iterations until the condition becomes false, and then we outside the loop we print a new line. This is a very wonderful task. So that's it, and we are moving to the next one. Our next task says that write a program that prints all possible combinations of single-digit numbers. Interesting. Numbers must be separated by a comma followed by a space. Numbers should be printed in ascending order. You can use putCal function. All your code should be in the main as usual. You can use putCal 4 times maximum in your code. You are not allowed to use any variable of type car. This is an interesting one. And then this is the output that they are looking for. So we see it's like the same thing we've been doing, but it's from 0 to 9. But this time around, they are separated by commas and spaces. And then What else? I can see that after the 9 there is no comma, so we have to give an exception here. So everything else is going to be separated by a comma and a space apart from the 9. Okay, so let's go try that out. So we are not supposed to use the character data type, so let's keep the same thing here. We don't need this, so we are getting rid of it. Then we're going to initialize our variable as 0, all right, because we are starting from 0. So we initialize as 0 and it should be less than or equal to 9, just like we have over here. Then we increment it, so it's like we're doing the same thing actually. Then since we are using the putCal function, of course we need to divide the number at whatever iteration it is by less 10, and it gives us the same number. We add it to the ASCII character conversion format, just like we've been doing in the past task. Then let's get rid of this because we don't need it. We need to give a condition, because remember that after 9 there should be no space and comma. So to give a condition, what do you use? We've done it in our first task, the if else statement. Whenever you hear conditionals, options, if something something, if something something, then you should know that we are dealing with if else statement. So if our number at a point is equal to 9, then what should we do? We bring our parenthesis and we are going to continue. Remember, I explained the continue to you because it's going to skip. The continue statement skips. Okay, so if our number is 9, then we are going to continue. Then after the skipping, what do? We put car. What do we print? We print first the comma. Then we put car again. What do we print? Now we print a space like that. Then we come out of the loop and then print a new line. So let's run this code and see what comes up. I like to debug, so whenever I run a code and I see, so you see we don't have our commas and spaces here, so let's go see what the problem is. Okay, let's try and see where our problem is coming from. Could it be from these curly braces? So let's get rid of it and see if that could be the problem. So I'm gonna run my code again. Voila. Okay, that's an interesting one. So we have our code. Let me clear my terminal, run this code again. Okay, so our code seems to be working fine, which means that we had to take the curly braces after our if statement. Well, I don't see why that should be a problem though, but if you know why that was causing a problem, you can leave your answer in the comment section below. Okay, so we're done with this task. Let's move to the next one. Yeah, now we are inside the advanced task, and these ones can be really troublesome. Okay, so let's see if we can crack this one. Write a program that prints all possible different combinations of 2 digits. Numbers must be separated by a comma followed by a space. The 2 digits must be different. 0, 1, and 10 are considered the same combinations of 0 and 1. I see. Print only the smallest combination of 2 digits. Numbers should be printed in ascending order with 2 digits. You can only use putCal. You can only use putCal 5 times maximum in your code. You are not allowed to use any variable of type car. All your code should be in the main function. This is a very interesting one. However, there is a trick that usually when I come across such questions I use. Okay, and so far I don't know whether it's absolutely universal, but so far it has worked for me, and that trick is what I use to solve all pattern questions. I've tried it on dozens and dozens of pattern questions and it seems to work fine. So far I've not encountered any exception yet, so I'm going to teach you that trick, and then you also try it out and see if it works for you. If you encounter an exception, I'm always here. You know where to find me. You can leave your comments down below. Okay, so let's go and see. Now, to be able to crack something like this, you're still going to need loops. However, this time around, you're going to need what is known as nested loops. Nested loops, which is a loop inside a loop. Okay, so let's go and then read a little about nested loops in my notes. And let's see what we can learn in a minute. Nested loops. So it says that a nested loop is a programming construct where one for loop is nested inside another loop. This means that the inner loop is placed inside the body of the outer loop. That's an interesting one. So let's see. The current loop that we know is that we declare our loop. So for we initialize it, our condition, then our update statement, then our block of code. But for nested loops, before you bring your block of code, the moment you open your curly braces, you bring another loop. So for another initialization, then there's another condition, another update, then you close your loop, you close your parenthesis, then you bring your block of code for the inner loop. Okay, then you close your parenthesis, then now the next statement for the outer loop comes here. So the outer loop before you close your outer loop parenthesis. So this is how the execution of the code works. So let's assume that you initialize this as 0. You said this is less than 5. You said you want to increment this. And let's say you also initialize this at 0. You said this is less than 5. You increment this. How is this nested loop going to be executed? Let's try it out. So we start our iteration at 0. Our I is 0. Okay. Now, is 0 less than 5? Yes, the condition is true. And I told you that it's not going to go to the update statement yet. It's going to come down to execute the block of code. But when it came down to execute the code, it encountered another loop. That's an interesting one. So what's it going to do? It's going to now check the condition of this loop. It's also initialized as 0. Is 0 less than 5? Yes, it is less than 5. So the condition is true. Now to come down to execute a block of code. Let's assume that the code that it wants to do is to print that variable. So since it is 0, it's going to print 0. Okay, then when it is done printing, since the condition is true, it's executed the code of the inner loop. It's going to go to the update of the inner loop, and then now 0 becomes 1 plus 1. Is 1 less than 5? Yes, that is true. So it's going to execute the code and print. So now we are going to have 1. Then it's going to come to the update. It's going to become 2. Is 2 less than 5? Yes. Then it's going to come. Is 3 less than 5? Yes. Is 4 less than 5? Yes. Is 5 less than 5? No. So this inner loop is going to break. Okay, this inner loop is going to break. Then we are going to come to the code execution for the outer loop. So let's say in the outer loop, we probably said we want to print a new line. Okay, so it's going to jump and then come to a new line. Then when it is done, it will go back all the way to the update statement of the outer loop. And then the initial value, which was 0, now becomes 1. So now we check the condition again. Is 1 less than 5? Yes, that is true. Then to come down to execute the outer loop code statement. But when it comes down, it encounters another loop. So it checks the condition. Now we are starting all over again. Okay, the inner loop is going to start all over again. So we are going to have the inner loop value is 0. Is 0 less than 5? Yes. So it's going to come down to execute the code. And let's say we are printing the variable. Okay, so it's going to print 0 because the initial value is 0. Then it's going to increment. Now it's 1. Is 1 less than 5? Yes. So it's going to print. Then it comes to increment. Is 2 less than 5? Yes. Is 3 less than 5? Yes. Is 4 less than 5? Yes. Is 5 less than 5? No. So the loop is going to break for the inner loop. Then when it is done, it come down all the way to execute the code statement of the outer loop, which is printing the new line. So it's going to bring the line over here. Then it is going to go to the update statement of the outer loop. Then now the value becomes 2. Now, okay, it started from 0. We came to increment, it became 1. Now we have come to increment again, and the value is now 2. Okay, so we're going to check. Is 2 less than 5? Yes, it is. So we're going to come down here to the inner loop again. Do you see how the nested loop works? It's a very interesting thing. So now we're going to start the execution of the inner loop all over again. Okay, but remember that we are at the third iteration currently of the outer loop. Okay, we are the third iteration of the, or is it the second one rather? Yes, I think we are the second iteration of the outer loop. But then we are going to start the execution of the inner loop all over again. So even though the value of the outer, the iteration of the outer loop is the second one, when we come to the inner loop again, we are starting from scratch. So is 0 less than 5? Yes, it's going to go all the way through again. Okay, then it's when the iteration of the inner loop is 5, the condition becomes false. So it's going to break out of the loop and execute the code statement of the outer loop, and then it brings it to a new line. Then iteration of the outer loop now becomes 3. All right, so it's going to go all the way through until the outer loop becomes false. Is 5 less than 5? No. So the outer loop is also going to break out of its loop and then continue with the rest of the statements in the program. Does that make sense to you? So you see, with just these two nested loops, we have been able to print out this pattern. And that is where the trick comes from. The trick, listen to me, here is the trick I'm about to tell you. You need to hear me out well on this trick. I'm going to make a special video on nested loops so that I can actually take my time and explain it very, very well. Now, the trick about nested loops is that if you look at the pattern that you are being asked to print, you are going to print the number of rows. So let's say there are rows and columns. In every matrix, there are rows and columns. So these are the rows and these are the columns. Okay, you're going to print the outer loop the number of times there are rows. So when you count, there are 1, 2, 3, 4, 5. There are 5 rows, which means that you have to go through 5 iterations. Do you understand it? So you print the outer loop the number of times there are rows. So you go through 5 iterations. Assuming there are 5 rows, then you go through 5 iterations of the outer loop. Then the inner loop controls the columns. So you need to find the relationship of the rows and the columns, and that is what you are going to use to control the inner loop. That's what will determine what is the inner loop is going to print. Okay, so when you print the outer loop to determine the number of iterations it's going to go through, that controls the rows. Then now you come to the inner loop, and then the inner loop, you're going to check the condition or the relationship of the inner loop and the outer loop, and then that's what will determine what you do for the condition over here. We are going to see examples of it. So let's go back to our task and then look at this pattern. If you look at the way ALX arranged the pattern over here, it might confuse you. So what you need to do is that before anything, check out the pattern. Realize that there are zeros, there are ones, there are twos, there are threes, there are fours, there are fives, there are sixes, there are sevens, and then there's the 8. Okay, so what you want to do is that if you have time, right now I don't know if I can have all the time, but copy all these just because you want to see what kind of pattern am I looking at here. Okay, what kind of pattern am I looking at here? You just want to see. So copy all these and then try and paste them somewhere according to how they are arranged. I didn't bring the 09. So let me copy this. I think this is 09 here. Great. Let me just run through it really fast. So they are the 2s. Okay, now so see what I've done. What I've done, I've just copied. This is the same thing that we were given. Okay, don't be confused. This is the same thing that we were given in the task. What I've done is that I've just copied them and I've arranged them in a certain pattern. Let me minimize this a bit so that we see clearly. Wonderful. So if you look at it, there's an interesting thing, there's an interesting pattern going on here. Okay, if you look at the first one, they are made of zeros, the second ones all the way to the 8. Now the trick is that you are going to run the outer loop the number of times there are rows. I told you, all right, you're going to run the outer loop the number of times there are rows, and you run it whether it's less than the number of times there are rows or less than or equal to, depending on whether you initialize it from 0 or 1. You're going to understand what I just said, don't worry. Okay, but first let's try and figure out the relationship of this pattern going on here. Now you realize that the outer loop is controlling the first digit. So let me maximize this a bit and explain it to you all. When the iteration of the outer loop is 0, the iteration of the inner loop is 1. So let's say we are running our loop and then the outer loop is in its first iteration. Then we come down to the inner loop. Then the inner loop is now at 1. Then we are still in the iteration of the outer loop because it's still 0. Then the inner loop moves to the second iteration, which is 0. Still in the iteration of the outer loop, the first iteration of the outer loop, the inner loop has moved to the next iteration. We are still in the same iteration of the outer loop, but the inner loop has moved to the next iteration. So all these you are seeing here is the first iteration of the outer loop, but then the inner loop is moving through its iterations all the way to the last iteration, which is 9. So you see, so from what you see over here, you realize that when the outer loop is, let's say, 0, the inner loop is 1. So the inner loop is the outer loop plus 1. If you don't understand that, let's use the next iteration of the outer loop to explain. So you realize that when we move to the ones, we have moved from the first iteration of the outer loop to the next iteration of the outer loop. Does it make sense to you? So now, in the next iteration of the outer loop, when that iteration is 1, the inner loop has moved to 2. When the iteration of the outer loop is still 1, the inner loop has moved to 3 all the way, and you can see that it runs through. Then after this, we move to the next iteration of the outer loop. When the outer loop is now at iteration 2, the inner loop is at iteration 3. So we go through all the iterations of the inner loop, then we move to the next iteration of the outer loop. Is it making sense to you now? So we are going to run the outer loop the number of times there are rows, and the inner loop, you know how to run it depending on the relationship between the outer and the inner loop. And as we can see over here, when the outer loop is at a certain number, the inner loop is that same number plus 1. And it runs, that pattern runs through for all of them. Just by looking at it, you can figure out that mathematical sense. Okay, so now let us go. Then one more thing, the last number is 89. Okay, and the last number too has something about it. There's a trick about the last number that you need to know, because if you look at it over here, the last number does not have the comma and the space, which means that you need to bring an if statement to say that the moment we have 8 and 9, you don't print the comma and the space. So let us go now into my Visual Studio Code and then try this out. Because we are using 2 digits now, we need to declare 2 variables. So we're going to have num1 and another integer, let's call it num2. Okay, then for our first outer loop, what are we going to do? Remember, I told you that you are going to run the outer loop the number of times there are rows. So let's count our rows. 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay, so there are 9 rows, or there are 9 rows here. So how many times are you going to run the outer loop? It's going to be less than what? 10, depending on whether you initialize it from 1 or 0. Okay, so let's go check. So since we are initializing our num1 from 0, then we have to run our outer loop less than 10. Okay, if we initialize it from 1, then we run our outer loop less than 9. But since ALX is saying that we should start printing our pattern from 0, as you can see over here, from 0, then we need to initialize our outer loop less than 10. Okay, so let's write our variable well, number 1, and then we increment number 1. So now let's come and figure out the relationship of the inner loop. So let's try, right after the outer loop, you come to the inner loop, and then that is num2. So we are going to initialize that 2 at what? Now take note of what we explained earlier. When num1 is 0, num2, the next iteration of the inner loop is 1. So we are seeing that the inner loop is num1 plus 1, and it runs through all the pattern. So that means that the inner loop is going to be initialized at num1 plus 1. Okay, then the condition is going to be that num2, how many times should the inner loop run? It should run the number of times the first column is. Okay, so num2 should be less than 9. Then we increment it. Okay, why is num2 running all the way to less than 9? That is because if you look at the last figure, the last iteration of the inner loop is going to end at 9. Okay, and if you look at this, the inner loop, the first iteration of the inner loop runs all the way till it's 9. So you're supposed to run the inner loop to be less than 9 because we are initializing it at 0. Okay, so let's go do that. Then what are we going to print? That's the next thing we need to figure out. So we're going to print, we are using the putCar function, so this is the same pattern that we're going to have. We're going to print our putCar num2 modulus 10, then we add it to 0 in single quotes. We're also going to need an if statement. If num1 equals to 8, then the logical end num2 is 9, then skip, okay, skip. But for the others, print the comma and the space. All right, let's try and understand what we've done here. So our outer loop is running the number of times there are rows. We are initializing at 0, so it's less than 10. Then our inner loop is our outer loop, the iteration of our outer loop, the current iteration of our outer loop plus 1. Okay, then the inner loop is going to run the number of times there are columns. Okay, then we are going to increment the inner loop for sure. So we are printing first the outer loop, then we are also printing the inner loop. Then we are giving a condition that if the first loop is 8, okay, that's because our last number, there's no comma and a space. The first loop is 8, okay, then the second loop is 9, then don't print the comma and the space. So let's print this, let's run this code and see what we get. We don't get the exact pattern, so let's go and debug. How many rows do we have? 1, 2, 3, 4, 5, 6, 7, 8, 9. Oh, okay. Then we should run the outer loop less than 9 instead, since we initialize at 0. And how many columns do we have? 1, 2, 3, 4, 5, 6, 7, 8, 9. Wonderful. So we should run this rather less than 10. Okay. Then we print num1 and num2. So let's run this and see what happens. Let's inspect the syntax carefully. So this is a curly brace of the outer loop, and the inner brace, the inner loop has no curly braces. That could be a problem. So now all this is inside the inner loop. Okay. And we need to bring the curly brace of the inner loop. So this curly brace is for the inner loop, and then this brace is for the outer loop. Okay, so let's bring that here. So let's inspect it carefully. So this brace is for the outer loop, and then this brace is for the inner loop. Wonderful. Let me run this code and see what I get again. It is working. It is working perfectly. So just as you can see, this is the exact thing that we need. This is the exact output that we need. We are printing the digits 0, 1, 0, 2 all the way to 9. Then we are printing the digits 1. We are printing all the way to 89. And after the 89, there are no spaces and commas. So this is the exact pattern that we are looking for. Okay, so let's just get rid of the new line of the outer loop and print our program and see what comes up. Voila, voila, voila. So you can see it's the same thing actually, just that we got rid of the new line after the iterations of the inner loop, and then we have this printed out for us. That's a very interesting one. So we could bring our new line completely outside both loops. So let's put car new line and print our program and see what we get. Voila, this is the exact thing that they are looking for. Okay, so we've come a long way. We came, this pattern actually gives you an idea of what is actually going on. So you iterate the outer loop the number of times there are rows, and you iterate the inner loop based on the relationship of the rows and the columns. That is exactly what we just did. Then we took out the new line and printed it exactly as it's supposed to be. So that is the trick about the trick about solving nested loops. Now when we try our hands on the next question, I think it will give you a bit more understanding on how nested loops actually work. Okay, let's be courageous and then try our hands on the next one. Like I always tell you, don't be afraid of challenges. The more you face them, the more you get better at coding. So when the challenges come, face them square on and move on. Don't be afraid of challenges. That is how we get better. We are all learning over here. Okay, so our next challenge says that write a program that prints all possible different combinations of 3 digits. Numbers must be separated by comma followed by space. Interesting, the same thing. The 3 digits must be different. So all these are considered the same combination. Okay, print only the smallest combination of 3 digits. The numbers should be printed in ascending order. You can only use the put car function. That's interesting, and we can only use it 6 times. All right, we are not allowed to use car as a data type, and all our code should be in the main function. Then, like I always like to do, I want to see how it looks like so that I have a fair idea. Now, I've shown you the trick. So you can start working on it. What would you do? Don't look at it like this. It won't make any sense to you. What's going on here? Nothing. It's like it's just a jumble of numbers and we don't even know where to start from. What you need to do is to separate them into patterns so that you can tell how many times the outer loop is supposed to run. Now, since we are dealing with 3 digits here, then you definitely know that you're going to run 3 nested loops. Okay, so that the outer loop will print the number of iterations, the number of rows, then the inner loop is going to print the columns. So the moment you see this, you know that we're going to run 3 nested loops. Okay, I mean a nested loop of 3 loops. All right, so the first thing you want to do is to break these down into the patterns you see. You can see that there are the zeros, there are the ones, there are the twos, there are the threes, there are the fours, there are the fives, there are the sixes, then there is the 7, just 1 7 here, and the last number is 789, meaning that when you get to these numbers, you have to create an exception that the moment the number is 7, the first digit is 7, the second digit is 8, and the last digit is 9, then continue. Don't print the comma and the space. So that's the trick with the last numbers. Okay, so let us break this down into patterns. Let me just fast forward and do it quickly. I'm gonna break this into patterns so that we can see how exactly it looks like. Okay, wonderful. So what I've done here is that I've just separated them into their patterns. They are the zeros, so I copied all the zeros and brought them here. I copied all the ones, all the twos, all the way to the 7. So what you are seeing here is the same thing that I've broken down this way, and this is what you want to do. This is what you want to do before you start answering pattern questions, or else you are going to be confused, I promise you. Because the moment you see this, it won't make any sense to you. You need to figure out exactly what to do before you start printing out your loops. Okay, so when I broke them down into patterns, I realized that there are 1 2 3 4 5 6 7 8 columns. All right, so how many times are you going to run the outer loop? You're going to run it definitely less than 8 times. Why? I keep saying that. Let me just take my time and break it down to you. So instead of numbering them from 1, let me rather start numbering them from 0. So let's say this is number 0. Okay, then this is 1, this is 2. Okay, so you see that I've numbered it from 0 now, and because I numbered it from 0, we have 7 rows now. So how many times are you supposed to run your outer loop? Less than 8 times, or less than or equal to 7 times. Does that make sense to you now? That is why I keep telling you that if you, depending on whether you begin your initialization of the loop from 0 or 1, that will determine whether you run it less than either 8 or 7 times. But we are beginning our initialization from 0. Okay, so we are going to run it less than 8 times so that it can run 7 times, or we can run it less than or equal to 7 times. That makes sense to you? So let's go try it out in code and see how this is going to look like. So I get rid of this or just work with it. Okay, let me just work with it. So since we are dealing with 3 numbers, we need to add 1. So now we have num3 in addition to num1, num2. Okay, so this is our outer loop. How many times is it supposed to run? We are initializing it at 0, so it's going to run 1 2 3 4 5 6. No, remember that we started from 0, so 0 1 2 3 all the way to 7. So we are supposed to run it 7 times. Okay, so our outer loop is going to be less than 8. Then we increment it for sure. Then let's look at the relationship between the first digit and the next digit. When the first digit is 0, the next digit is 1. Then let's check it for another. When the first digit is 0, the next digit is 1. That's for the first iteration of the outer loop. So for the first iteration of the outer loop, it's going to remain 0. For the first iteration of the outer loop, it's going to remain 1. So you're going to see 1 as the first digit throughout each pattern, each row. Okay, so that the reason why it's that way is because it's the iteration of the outer loop that's running. So for the first one, we are for all of this, we are in the iteration of the outer loop. So it's going to remain 0. So the first digit will remain 0 throughout. And then for all of these, we are in the iteration of the first iteration of the outer loop is +1. For all of this, we are in the second iteration of the outer loop, so it is 2. That is how it runs all the way to we are in the 7th iteration of the outer loop. Okay, now the second one represents the second iteration of the first iteration of the next loop, the second loop. Okay, so realize that when the outermost loop is 0, then the next loop is 1. Okay, so it means that it is the number of the outermost loop +1, just like it was in the first task that we did. All right, so let's go implement that in code. So it means that for our next loop, we're going to be looking at the number 2 is equal to the number 1 + 1, just the same way we see over here. Okay, then we're going to create another inner loop again because we are dealing with 3 digits. And we're going to see that the number 3 is equal to number 2 + 1. Does that make sense? Because it's the same thing. Then our number 3, how many times should the outer loop run? We're going to come to that. Then we're definitely going to increment num3 ++. We'll bring our curly braces. Let's not forget that. Let's print put car. So we're going to print our num3. Definitely is going to be modulus 10. You already understand why this is so. We're going to add it to this for the ASCII conversion. Okay. Then we're going to bring an if statement that if number 1 equals to 7 and if num2 equals to 8, logical and again, if num3 is what? 9, then continue. For the others, print the comma and the space, but for these numbers, do not print the comma and the space. Does that make sense? If num1 equal to 7, yeah, num2 equal to 8 and num3 equal to 9, because we are looking at 7 8 9 over here. Okay, so let's now figure out the relationship between the columns and the rows. So we realize that the columns is always one iteration ahead of the row. So if this is 1, this becomes 2. So since we run this for less than 8 times, we definitely need to run this, because it's +1, we need to run it for less than 9 times. So we're going to run this for less than 10 times because it's always +1. Okay, so let's run this and see if there are errors. If not, then we're going to debug. So 2 errors generated. We didn't bring our curly braces for the outermost loop. Our code seems to be working fine. So let's just quickly run through it one more time and see what we have in there. So we used 3 loops to be able to print this pattern. It looks a little convoluted, but actually it's not. We declared 3 variables, num1, num2, num3. When the outer loop ran the number of iterations there are rows, which is 7 times, so it's less than 8. Then the inner loop is the inner loop relationship with the first outermost loop is the current iteration +1, and then the innermost is the iteration of the second loop +1, just as we saw in the pattern. Then it ran the number of times +1 as the outermost loop, and then equally as the innermost loop. Okay, take your time and go through this code very well, think through it, and then you're going to realize that the understanding will begin to come to you. As for this, I think it's straight to the point and you really know why we did this. Then we said if the number 1 equals to 7, if the number 2 equals to 8, if the number 3 is 9, then skip, don't print the comma in the space. So that is the code that gave us this output. Okay, so that is it for nested loops. Let's try our hands on the last advanced task and see what we can do. Okay, so now for our final advanced task, says that we should write a program that prints all possible combinations of two digit numbers. That's really funny. Two digit numbers. I don't know what they're trying to do. The numbers should range from 0 to 99. The two numbers should be separated by space. All numbers should be printed with digits, with two digits. One should be printed as 0, 1. Okay. The combination of numbers must be separated by comma followed by a space. I think we can do that. The combination of numbers should be printed in ascending order. We've seen that too. So this is what they are looking for. Okay. So these are considered as the same combination of 0 and 1, which means you shouldn't repeat. Then they are saying we can only use put car. We can use it 8 times. We can't use car, and our code should be in the main function. Then this is the output they are looking for. Let's see how it looks like. Usually I want to see the pattern, but it looks like this pattern is really going to be a lot. So you can see that there are some 3 dots here indicating that there's much more. This is really a lot of code. This is a lot of code. So since we're not going to have the opportunity to create the pattern manually like I would do with simple patterns, now we need to come up with another way to find out how many times will the outer loops iteration run, and then how many times will the inner loops iteration run. But we know that we are dealing with 2 digits, so definitely we're going to need 2 variables. But the question is, how many times will the iterations run, and then how are we going to print them? So one other trick that you need is that always look at the last numbers. Okay, so for instance, with the previous tax, the last number was 789. Now this simply means that the outermost loop is going to run the first number of times, 7 times. The next loop will run 8 times. Then the next loop will run 9 times. Now for the other one too, the outermost loop was going to run 8 times, and then the inner loop will run 9 times. Okay, so if you like, you can refer to the history and realize that's how it was. Now for this pattern, since we cannot create the pattern manually, we are going to look at the last number and see how many times will the outermost loop run. Realize that it's going to run 98 times, and the innermost loop is going to run 99 times. But then how we are going to print out to have this exact pattern is what the problem is going to be. Okay, so the rest is easy, but how to exactly print out to have this pattern is what we need to take need to take a critical look at. Let's go into my VS Code and then let's try and work on it. So this time around we are dealing with 2 variables, so let's get rid of this. And then for the first number, we initialize it as 0, of course, and then this time around we are printing the outermost loop 98 times. Okay, so let's say it's less than 99. Okay, then we increment it, of course. We are dealing with 2 variables now, so let's get rid of a 3rd loop. Of course, let's get rid of its parentheses as well. Great. So for the second loop, num2, as usual, it's going to be the num1 plus 1, because if you look at it carefully, in the first iteration, when you print the outermost loop and it's 0, the next one is 1. When you print it 0, the next one is 2. So even though we are in the first iteration of the outermost loop, the innermost iteration keeps running and running. So it's the first variable plus 1 as usual. Then how many times is this also going to run? It's going to run the number of times we have the last number, which is 99 times. So we can see that this is also less than 100, so that it can run 99 times. Or we can even say that it's less than or equal to 99 times. Okay, it's the same thing. Then we're going to increment it. So the question now is, let's get rid of this because we don't need. What are we going to print? All right, let's look at the pattern carefully. We see 2 numbers printed, then there is a space, and then 2 digits. So 2 digits, the space, 2 digits. And this is the digit of the first iteration. This is the digit of the second iteration of the innermost loop. So let's try and come up with a logic by which we can do this. All right. But before we even wrap our mind around this, let's just clear this if statement. So if the first number is 99 and the second number is 98, then we are going to skip. So if number 1 is 99 and if number 2 is 98, then let's continue, which means that we're going to skip. We already understand this and how it's working. All right, because the last 2 numbers do not have the commas and the space. Okay, so we are done with this. Now let's come up with a logic as to what we are going to do about this. So before we do that, let's print this code and let's see the output that we get. Wonderful. So we are getting, that's a lot of code. That is a lot of code. So what we are getting here is that we are getting 01, 02, 03, 04 because we are printing 2 digits. So put car num1 modulus 10. So we are printing the variables num1 and num2. So in the first iteration of the outermost loop, the innermost iteration keeps running and running and running, and then the process is repeated. So there are all the zeros, all the ones. This is what we have seen so far. But then the pattern we are seeing with this question means that another set of digits must be printed. However, there should be a space between them. Okay, so let's start working on that. Now let's put car again and work on the space. So let's create a space. We're gonna put car here, and I'm gonna run this code again and see how it looks like. That is a lot of code. So as you can see now, we have separated a digit. There is one digit and then there is another digit, and then they are separated by a space, which means that we need to add another 2 more put cars to be able to get the exact pattern that we are looking for in our task. This is a lot of code. I mean, a lot of output. Wow. So we have 0, 1, 0, 2. Let's go look at our pattern. We have 0, 1, 0, 2, 0, 3. So we need to add some additional put cars over here. So let's go work on that. Let me delete this. So since we are having the pattern of the 0, 1, 0, 2 for the second digit, so we have 0, 1, 0, 2, 0, 3. It means that we need to print some more items ahead of them. So what are we going to print there? So for here, I'm going to have just a moment so that becomes clean. Another put car here. Then I'm going to have another put car here. I'm going to print num1 divided by 10, and let's do our ASCII character conversion. Then I'm also gonna let me bring my semicolon first. For this, I'm also gonna print my num2 divided by 10. I'm gonna add it to do the ASCII character conversion. I'll bring my semicolon here. Okay, why do I have a syntax error here? Oh, I use the backslash instead. It's supposed to be this. Okay, let me run this code and see if it works. If it works, then we can find the logic. Okay, it seems to have worked perfectly. Let's see the beginning of the code. Wonderful. Guess what? So let's explain what we did. Now, the reason why we are doing this is because we are trying to get the exact pattern that you're looking for. Okay, so we already understand this syntax, the number modulus 10, and we add it to the ASCII character conversion, what it does. But why are we doing this? Okay, now you have to understand that whenever you divide an integer by an integer, even if you get a decimal number, the fractional part is going to be discarded. So for instance, if let's say I divide, let's say 98 by 10, okay, my answer is going to be what? 9.8. okay, but because we are dealing with integers, the 0.8 is going to be discarded, and then the answer is going to be 9, because I'm dividing an integer by an integer. That's what happens in C programming. So if you want to divide and then have the fractional part added to it, then you need to use the data type, which is a float. But since we have already indicated in our code that our numbers are integers, whatever we divide, the fractional part is discarded, and then the number remains the single number. Okay, so now let's say we divide our number. Let's say the iteration has gotten to the number 97. Okay, we divide 97 by 10, and we add it to its ASCII. We convert it to its ASCII character representation. Now this is going to evaluate to 9.7 plus the ASCII conversion. Okay, so since we are dealing with integers, this 0.7 is going to be discarded. So now we are going to have 9 plus. Now we are converting the 9 to its ASCII representation. All right, so which means that the ASCII conversion is going to be done, and then eventually the number 9 is going to be printed to the console. Now look at our pattern here carefully. What we are looking for is that now this is the print of the modulus, okay, but in the first one we are looking for a pattern that the first digit remains in the same number while the iteration of the second digit is running. For instance, if you look at this pattern, for instance, this pattern over here, for instance, while the iteration of the second digit is running, we are still in 4 4 4 4 4 4 4 4. All right, so if you look at it carefully, we want a figure that will remain the same while the iteration of the second digit is running, and the only way to do that is to use the division operator. Okay, so for instance, if we are running, let's say we are in the 19th iteration. Okay, so what we are doing is that we divide the 19 by 10, which gives us 1.9, and because it's an integer, the 9 will be discarded. All right, so we are just going to have 1, then we are going to add it to the character conversion of ASCII. So this is going to output 1 to the console. To realize that even though the iteration of the second digit is going to keep running and running, we are going to have the same digit all the way until the iteration is done running. So while this iteration is running, this first one is going to remain at the same digit, and while this last iteration is running, this one is also going to remain the same digit. So that is how you can get this pattern. It looks a little convoluted, but when we take our time to look at it carefully, it all begins to come together. It's been a long journey today, and we've been able to learn a lot of things. We've learned about nested loops mostly. We've also learned about some logical operators, the logical AND, logical OR, and then the NOT operator, and then a few more things. Thank you for watching, and I love sharing time with you. And till we meet again, subscribe to this channel for all the work that we're doing, and then like, share, comment. Let me know what you think. If you think that something was not done right, leave it in the comments section below, because we are all learning together. Thank you for watching.